Hi, my name is Enrico, and in this video I'll show you how to integrate and operate Pachyderm along with Seldon deploy. Just a quick summary of these two systems first. Pachyderm is a data layer that brings together data version control and automated pipelines, providing lineage. You can build data processing workflows where each step is tracked and version controlled automatically for you. Seldon Deploy is the enterprise product that extends Seldon Core open source functionalities to deploy machine learning graphs. It comes with a dashboard, a REST API, and even a Python library for easy use. On top of that, the Seldon Alibi package has a set of tools to monitor closely your deployments for unwanted behaviors. Both of these systems are built on top of Kubernetes. That means they are perfectly capable of scaling out to any workload and can run natively on the cloud or on-premise environments. The purpose of this demo is highlighting how Pachyderm and Seldon Deploy can be integrated to create an end-to-end machine learning deployment, from model training to monitoring a live instance. Dealing with live data is a non-trivial task. Definitely from a controlled lab, live data is always growing and changing at a very fast pace. That means you always want to keep an eye on what your models are doing and early detect any unexpected situation. Pachyderm takes a data-centric approach. It keeps datasets, models, and pipelines close to each other so that it is easy for your team to manage them. The benefits of integrating Pachyderm with Seldon Deploy are multiple. With Lineage, you can always track a model down to its source dataset. And with automation, your entire pipeline reacts to input changes and trains fresh models as soon as new data becomes available. And with monitoring, your live models are constantly watched over so that you can early detect problems. In the first part of this video, I'll explain how to create a Kubernetes cluster and install prerequisites for the second part, which is a walkthrough an example credit institute that employs machine learning for its services. They're going to face real-life challenges in live machine learning, but thanks to Pachyderm and Seldon, they will manage them successfully. I'll show you how and why that is possible. Before I dive into the installation process, I would like to give you a glimpse of the demo repository. Now, there are three folders. The first two being related to the set of options we provide for running this demo. In fact, you can do this on Google Cloud or on a local machine. The third folder contains the tutorial or demo notebook. This will be shown in the second part of the video. A Docker container in these other folders that specialize in training a specific set of models and deploy them into Seldon. Let's start with the installation of the prerequisites for the demo. Head over to the GKE install folder where you'll find a README with step-by-step instructions. Hereby we'll install Pachyderm and Seldon Deploy with related dependencies. Now, Seldon Deploy requires you to install a set of packages for a number of use cases that I'm going to detail soon. Before stepping into that though, make sure you have a Google Cloud SDK client installed in your local machine and you've Docker running to extract Seldon Deploy installation files, and your account should also have enough quota to create the cloud resources we're going to need. For creating a cluster, you can just run these commands. Here I'm specifying a number of nodes as 3, so we need a 8 vCPUs machine to run the full demo seamlessly. Seldon Deploy needs Istio and Knative serving. Now, Istio is a system that is in charge of routing inbound requests to Seldon pods. And knative serving is going to be used to spawn stateless workloads such as Seldon models. We're going to install these via Antus, which comes along with the gcloud suite. This is also going to create an HTTP load balancer. Right after that, we can create a Istio gateway for Seldon. This is going to expose a Seldon API on port 80 to the external world, which is the entry point we'll be using to deploy our models. Now, side note, if you're running on a private cluster, you may need to open a specific port. Here are the instructions if those are needed. Now, Seldon pods need a way to communicate with each other, and Knative eventing provides a message bus that does exactly that. So we're going to create also a Knative event broker, which will allow this communication among pods. This is going to be created in Seldon logs namespace. Right after that, we can just install the Seldon core open source component. We now download the installation files for Seldon deploy, install Elastic and Fluentd and Kibana to allow Seldon deploy to make logs searchable and presentable on the UI. Then, because we have already extracted Seldon deploy installation files, we can just run the installation of them. We need to make sure that the Seldon namespace is visible so that any container that is going to be deployed within that namespace is going to be visible on the Seldon deploy UI as well. As the last dependency to Seldon, we need to install the analytics package. This is necessary to collect and process monitoring logs from components such as the drift detector. Now, in order to reach the Seldon deploy UI, from our local machine, we'll have to run this port forward in a separate terminal. Right after that, just visit this URL, and where you will be able to activate your Seldon deploy instance with a license key, and then just use the UI. It's almost time to install Pachyderm. First, we install the client locally, and then we're going to use the Pachyderm native deploy on Google installer. So this requires you to create a storage bucket first. You may also want to use a storage size of 10 gigabytes. That is going to be enough for this demo. It's going to be necessary to create custom cluster role bindings for your user account so that Pachyderm can proceed with its deployment. Once that is done, Pachyderm is going to deploy in one line of code. Pachyderm also comes with a dashboard. In order to have that accessible from our machine, we'll have to again run a port forward in a separate terminal. When that is running, we can visit this URL and activate and use our Pachyderm dashboard. Last step is the creation of a cluster role binding for Pachyderm workers. This is necessary so that pipelines can create Kubernetes secrets that Seldon containers are going to use to pull models at deployment time. That's all for the installation. We can now move on to the demo notebook. In what follows, I'll get you through a story of Credico, an hypothetical credit institution that employs machine learning to predict individuals' creditworthiness. Credico is a fast-growing company, rolling out its services first in the US market, but with the ambition of scaling out globally. However, as the company expands, its data changes as well. Hence, it needs a flexible ML infrastructure capable of monitoring live deployments and quickly adapting to changes by retraining models as needed. What I'm going to show is a typical release, update, rollback, fix, and re-release cycle in a live system. If you follow the first part of the video, you should now have a Kubernetes cluster fully set up. To run through this notebook, you need a Kubernetes client installed, a Pachyderm client as well, and the ability to pull Docker images from public Docker Hub into your cluster. This demo works for Pachyderm 1.13, but it should also work with subsequent versions. And so we're dealing with data in this notebook. I'll just start by populating the input data repository with the first CSV dataset. As you can see, Pachyderm automatically tracks this operation and creates a commit. Pachyderm dashboard is also displaying this newly populated repository along with some other details. All right, it's almost time to create our machine learning pipelines. Essentially, they will train a variety of models based on the input data set. The result is a set of artifacts that Seldon will deploy later on. Here's the income model training pipeline. The input to this pipeline is the income dataset hosted on this repository that I populated a few moments ago. This pipeline is based on a pre-built container. It runs scikit-learn, a popular Python library for machine learning, and it trains a logistic regression forecaster. Now, without going into the details, this is a statistical model that takes inputs such as age, occupation, and others to predict whether an individual is eligible for credit. The next training pipeline generates a different type of model. This time I use Seldon Alibi to create a model explainer. This is the first out of the three models that we are going to create that we'll use as a monitor tools. And the way it works is that it takes a forecast and it points out to the features that impacted it the most. So, in other words, given a prediction, it studies its vicinity in a mathematical space, working out how different features combine together and resulting in that specific forecast. Follow the Alibi the documentation link for further details on this step. Next, I create a drift detector training pipeline. Drift is a phenomenon that affects live machine learning systems, in which the relation between model input and the predicted variable changes over time. A drifted model is likely to be unstable, so it is best to use a drift detector to check for that. It will throw an alarm if it detects something wrong, and it usually indicates it is a good time to work on a new model. The last pipeline is for outlier detector training. Now, this is another monitoring tool based on Seldon Alibi. It is in charge of inspecting incoming requests to our deployment and compare their features with the train threshold and flag those that have out of ordinary values. Now, if we go check the Pachyderm dashboard, we can now see a more structured dependency graph. Thanks to Pachyderm automation, as soon as a new dataset is added upstream, the training pipelines will fire and create fresh artifacts. For convenience, I'm adding one more pipeline that collects all artifacts into a single location, which I call copy models. Instead of copying files physically, Pachyderm allows me to use symlinks, very thin substitutes that act as file pointers. You may want to read more about the empty file spec on Pachyderm documentation to understand how to keep this efficient. Current state is, I have all models stored in one single location, but I want to decouple training and deployment because for deploying, I do want to have a human in the loop that decides which version of the model should go live. Here I create a deployment service. A service is a special type of pipeline. It is designed to expose data to the external world rather than transforming it. In this case, I use it along with S3 inputs enabled. This means that the deploy production branch of copy models is exposed as an S3 endpoint. I pass the S3 endpoint URI to the deployer script as a parameter. With this environment variable, Seldon will simply fetch the models from this S3 location and deploy them. Okay, now that all pipelines are ready, Critico wants to go live. To deploy model V1 in production, all I need to do is some branching work. So I move this branch head to master so that it points to the latest model version. Thanks to Pachyderm automation, the new artifacts are going to be created automatically, and Seldon is now launching its pods. Once Seldon pods are ready, we can actually check its user interface and visualize a deployment. Now, thanks to Pachyderm's provenance model, Critico can anytime check the model version that is being deployed simply by matching the commit hashes from the model repository with the ones stored in the Seldon container. The first model is live, and the company's customers are sending credit assessment requests. Now, for demoing purposes, I simulate this step with a test dataset, and I just prepared in advance. It contains a number of requests, and Seldon is going to return multiple predictions. So to do that, I use the predict upload JSON file functionality, and there you go. As part of the monitoring process, the company wants to check for model drift. Now, Seldon has a specific view for that under monitor and drift detection. And we see that this check returns negative. Critico is committed in making sure its ML model is fair, specifically with respect to minority groups. So the company has included a model explanation check in its monitoring process. The data team inspects a number of predictions using Seldon Explainer. To do so, open the Request tab and click on the Explainer logo attached to each prediction. This page shows the most impactful variables for this given prediction. It seems that there's no reason for being concerned for now. In the meantime, the company has been growing a lot, and its service became popular, and the user base has grown as well, including more and more non-US native individuals. This is surely a good sign for a business unit, but this new user group has now shifted the actual data distribution. I demoed this scenario by submitting a new test set to the model and then go back to the monitoring and drift detection tab to check and actually find that there is a drift being detected by our drift detector model. This means the current model version is no longer suitable for its purpose. Critico is now running in deep waters and needs a new model. To react quickly, it requires a dataset from a vendor. Dataset is specifically built to represent well the new user group. To train a new set of models, all I need to do is push V2 dataset into the input repository. Again, all I need to do to create a new deployment with the latest models, I have to point the deploy production branch to master and wait for the deployment to roll out. I just deployed model v2 and it'll say it's running for a while, and now the company gets more requests. And simulate this scenario again, I'll submit yet another test data set. As part of the monitoring procedure again, the team goes out in the requests tab and checks for problems such as outliers. As usual, the team checks incoming requests and This time, well, they found out that the outlier detector has thrown in a red flag. So an investigation starts, and they use model explainer to understand a little bit more about what's going on. The investigation finds out that this model version is now using gender to make predictions and systematically denying credit to female clients. This is a ticking bomb situation for Credico. If this went public, the company would have to deal with a serious scandal. Credico decided to roll back to model V1. Why? Because that didn't show this rogue behavior. V1 models are still available in their Pachyderm repository, and it is enough to move the deploy production branch head to the target commit in order to roll back to this specific version. The emergency has returned, but Credico still needs to upgrade its models. This time we decided to deploy it in a staging environment, validate it, and only in case push it forward to production. Seldon deploy supports a variety of rollout strategies. I'm going to use a shadow approach. That is, incoming traffic is routed to both the main and shadow model. But while the main model operates as usual, the shadow predictions are kept private and for internal use, such as validation. So I created a specific deployment service for staging models, and I'm going to reuse a container created for the initial deployment, but this time I'm running a different script that is in charge of simply adding a shadow model to an existing Seldon deployment. I proceed just by running through the usual steps. So this time I'm pushing V3 through the Pachyderm graph. This will create new models, and then I deploy them in the staging pipeline. I can double check the deployed versions, and so I can see that the staging version actually matches the latest models, while the main production model it's been rolled back to the very first model training run. To fast forward a little bit, let's assume that the data team has validated shadow behavior and the company is happy with it and wants to promote it to production. Now, Seldon has a specific button for doing so, but hold on a second. I'm just going to use Pachyderm and preserve full provenance. How do I do it? Well, by simply pointing the production deployment branch to staging, and this will promote the model automatically. As a last step, I'll just double check the production main model version with the model repository commit hash. These two match, so I'm happy with it, and we'll reach the end of the demo. That's it for this demo. We've seen how to manage and monitor ML deployments with confidence by using Pachyderm and Seldon deploy. This notebook is publicly available on Github. Just check out the notes for further details. Or if you're interested in learning more about MLOps and Pachyderm in general, or talking to me, my name is Enrico Rotundo. I'm with Windows Research. Check out windowresearch.com. Thank you very much.